Hello class, this is the last part of our lecture from 1.6 today, and this one's pretty much just going to be all about what we call U-substitution. Alright, so an equation is said to be quadratic in form if it can be written as a times u squared plus b times u plus c equals 0. And if you look at it this way, it looks like something we can put in the quadratic formula and or factor, and that is exactly the case. So let's see how this U substitution can be used on different types of equations that we can see, so that we can use our techniques that we've already gained with quadratics. Now, when I'm looking at these, my biggest hint is going to be the kind of first degree term, if you will. That sets the standard for what u is going to be equal to. Because if you look at the difference between the first two terms, they both have the same denominator, but they have different numerators. And remember, the denominator represents a radical, so these are both cube rooted, and the numerator represents the power. So this is still the second power, right? So technically, I could write this term, I could write this as the term that I have highlighted. All right, I need to highlight all of it. I could express it as the term that I have highlighted raised to the second power. So I have, x plus 1 to the 1/3 power. And if I raised that to the second power, I would still end up with what I had here. So I can use this as the basis of my U substitution. And I'm going to do that by let U equal x plus 1 to the power of 1/3. Now when I rewrite this equation, I have u squared minus u minus 2 equals 0. And this allows me to factor and solve this particular quadratic equation and then substitute values in. We can allow them to do a lot of the heavy lifting for us. We know how to factor, but if you need a repetition, I would encourage it. So they end up with u sub 1, we'll call it u sub 1 equals 2, and u sub 2 is negative 1. So now at this point, you would substitute back in what you let u equal, and we'll do that up here. So we would have x plus 1 raised to the power of 1/3 equals 2. And I'm going to do this other one off the side here. And we would have x plus 1 to the 1/3 power equals negative 1. And we can solve those. So if I cubed both sides here in this first one, I end up with x plus 1 equals 2 to the cube root, or excuse me, 2 cubed is going to be 8. Subtract 1 from both sides. One of my proposed solutions is x equals 7. For my other, I cube both sides. And I have x plus 1 equals negative 1 cubed. Now, negative 1 times negative 1 is positive 1 times negative 1 is still negative 1. I subtract 1 from both sides. My other proposed solution is negative 2. Now, you would go and test these two solutions. So you need to test x equals 7, and you need to test x equals negative 2 in the original equation to make sure they make sense. Now, because these are cube roots, they're going to be more flexible, so I'm not worried about them violating anything, but I am worried about not getting the correct answer. So for the rest of these U substitution problems, I'm going to focus on how to set up the U substitution versus how to completely solve. So remember how I mentioned earlier that looking at that x, the x term is probably your best bet to determine what you need to let u be equal to? Because if you let u equal x to the negative first power, our equation turns into 6u squared plus u equals 2, which we can then put in standard form. All right. Now, looking here, this is also quadratic in form. It's a little hard to see, but if you notice, x squared would be x to the fourth. Like I could rewrite this over here as 12 times x squared squared. So if I let u equal x squared, this equation turns into 12u squared minus 11u plus 2 equals 0. And let me remind you, when you get something quadratic in form like this, you can factor it, you can use the quadratic formula, but now that it's, because it's quadratic in form, I can solve it for u, and then I can plug u back into my original equation. All right, so once you solve for it, like they'll solve for it here, they get that u equals 2/3 or u equals 1/4. That's when you want to plug in at what u was. U was 1x squared. And you can take the square root of both sides. Now, this one we may need to talk about. This one, actually, we'll talk about both of these. So when we simplify these two things, x equals plus or minus the square root of 2/3. Keep in mind we are going to have to rationalize the denominator here. So to rationalize the denominator, I need to multiply the numerator and denominator by the square root of 3. The denominator makes it easier for us because that's just going to end up just being 3. But the numerator, we're going to have to use a property where if I have the square root of a times the square root of b, that's equal to the square root of a times b. And if you notice, I have the square root of 2 times the square root of 3. That's going to end up being the square root of 6. Now, for the other one, this one's not so bad. We have x equals plus or minus the square root of 1/4. That's equal to plus or minus the square root of 1 over the square root of, I'm getting ahead of myself, the square root of 4. The square root of 1 is just 1. The square root of 4 is 2. And I think that's all for this section. Yeah. Let me know if you have any questions. Peace.